Hello students, today we are going to do part 12 of the lecture series. We are doing chapter number 9 and the chapter number 9 is ray optics. In the last lecture we studied about optical instruments and the very first instrument we have done, that was your simple microscope. In simple microscope only one lens is there, but today we'll study compound microscope. And compound microscope is named so because there are two lenses. It is the combination of two lenses, and that's why it is called compound microscope. Okay, let us start. What is a compound microscope? The compound microscope is actually used to view very magnified images of very small objects such as microorganisms and sometimes of very small objects which cannot be seen with our naked eyes. A compound microscope can produce magnification of 1000, and means it simply means that it can produce an image which is of 1000 times in size of the object. That's why it is used for research. It is used in biology to study the microorganisms. You must have seen compound microscope in your biology laboratory. So what is a compound microscope? Let us define this. So it is used to view magnified image of very small objects. The compound microscope can produce magnification of the order of 1000. How the compound microscope is constructed? So let us see a construction. Actually, what happens in the compound microscope, there are two lenses. One lens is called objective, other lens is called eyepiece. Objective is called so because object is kept in front of the objective, and nearby the eyepiece we keep our eyes. Now what happens? These two lenses are of short focal length. But the focal length of eyepiece is comparatively larger than the focal length of objective. I'm not saying that the focal length of eyepiece is bigger. It is of larger value. Actually, it is of short value, but comparatively it is of larger. Means focal length of eyepiece is greater than the focal length of objective. Now, one more thing. The aperture of the eyepiece is greater than the aperture of the objective. Why it is done so? Because my compound microscope is used to view images of very small objects. So we need more light for the making the image. So aperture of eyepiece is taken greater so that more amount of light is involved to make the final image. If aperture is large, then what happens? Larger amount of light falls on the lens and larger amount of light makes a brighter image. And that's why aperture of the eyepiece is taken larger in comparative to objective. So it means that focal length and aperture of the objective both are smaller than that of eyepiece. So in construction we have to write a compound microscope contains two convex lenses placed coaxially, means they have a common principal axis at the end of two sliding metal tubes. The two convex lenses are called objective and the eyepiece. As I have told you, both the convex lenses are of short focal length. Objective is a lens of a small aperture and it is positioned nearby the object. This thing I have explained you. And the eyepiece is of comparatively larger focal length and is of larger aperture. It is positioned nearby the eye. As we have done in the simple microscope, in the case of compound microscope also, we are going to do two cases. Case 1 is when the final image is formed at least distance of distant vision. I hope you remember in the last video lecture we have discussed the least distance of distinct vision. It is the nearest distance to after which we can see the objects. It is the nearest distance for a point object, for an object, so that we can see the object clearly. And its value is, for a normal vision, its value is 25 centimeter. Now we are going to discuss how the image is formed at the least distance of distinct vision. For that, we need to see the ray diagram. Just look at the ray diagram. One object is there. Object is AB. Okay, object is AB. Object is kept just after the focus of the objective. Just after the focus of the objective means nearby the objective is slightly greater the distance from the focal length. The object is kept in front of the objective lens. Now what happens? One ray comes parallel to the principal axis. One ray, let me show you. One ray comes parallel to the principal axis, goes through the focus. Another ray through the optical center. It cuts the first ray at B dash, so we get an image. And we get an image, and that image is A dash, B dash. Now what happens? From A dash, B dash, this image will serve as an object for the eyepiece. The distance between the lenses are so adjusted that this very distance, A dash, B dash, it falls between the focus of the eyepiece, as you can see, and optical center of the eyepiece. So what happened? This serves as an object. An object is between optical center and the focus of the eyepiece. So eyepiece makes a virtual magnified image of this image A dash B dash. And how it will make? So again, one ray parallel to the principal axis passes through the, as you can see, focus of the eyepiece. Another ray through the optical center and goes to our eyes. When we extend the rays behind, so we have an image, and that image is A double dash B double dash, and it is nearby something object. Every time it is not nearby the object, sometime it differs, depends upon the length of the compound microscope. But while making the ray diagram, we used to do so. What we imagine? We imagine that the distance between the image and the eyepiece is equal to capital D, because this is the case we have decided where the image is formed at capital D. I hope it is clear. Now, how will you write working? So for writing purpose, we have notes. Working. The object is kept nearby the focus of the objective at a distance slightly greater than the focal length of the objective, as I have told you. Greater than the focal length of the objective, full stop. The distance between the objective and the eyepiece is so adjusted that the magnified image formed by the objective is between focus and the optical center of the eyepiece. As I have told you, A dash B dash is between focus and the optical center of the eyepiece. The eyepiece produces final image which is highly magnified, and that highly magnified image is A double dash B double dash. Now what we have to do? We have to derive formula for magnifying power of compound microscope for this case. So now let us define magnifying power. So how we will define the magnifying power here? So what we say, the magnifying power is defined as the ratio of visual angle subtended by the image. Where it is in the ray diagram, let me show you. It is here, beta. Visual angle subtended by the image at the eye to the visual angle subtended by the object. I have made the separate ray diagram for that. That is your alpha. When both are at the least distance of distinct vision. When both are at distance of capital D from the eye. Then mathematically we can write M is equal to visual angle subtended by the image at D upon visual angle subtended by the object at D. Visual angle subtended by the image, it is beta. Visual angle subtended by the object, it is alpha. So M is equal to beta upon alpha, which is approximately equal to tan beta upon tan alpha. It is the same old song where we used to say that the angles are so small so that we can write tan beta in place of beta, and we can write tan alpha in place of alpha. Now just see in the ray diagram, what is the value of tan beta? So for tan beta, there are two triangles. Just see, one is this smaller one, E A dash B dash, if you are able to see, and another one is E A double dash B double dash. So in these two triangles, beta is there. So which triangle we should consider? The answer is you can consider any one of them. Answer will be there. You can determine the final relation by considering any one of them. In this case, I have considered the smaller triangle, that is your A dash B dash and E. So for this triangle, tan beta is equal to A dash B dash, it is your perpendicular, upon base, and that is E A dash. So we have written A dash B dash upon E A dash. It is for the tan beta. For tan alpha, what we should write? So just see that diagram at the bottom. The perpendicular is AB, upon base is E dash A. E dash A. So it is AB upon E dash A. Okay. Now putting the values, A dash B dash is written as minus H dash. H is the height of object, H dash height of the first image, H double dash height of the final image. Okay. So H dash is the height of A dash B dash. So in place of A dash B dash, we have written H dash, and it is minus because the image is inverted, upon minus U naught. Just see, I have shown the distance. Here, this U naught from lens to the image. This image is serving as an object. It is denoted by U naught. So U naught is the distance. Okay. So minus U naught written because we are moving leftward. All right. So A dash B dash upon minus UE. E, it is not U naught, it is UE, upon AB. AB is the height of the object, it is H, upon minus D. Again we are moving leftward. Now what will happen? We can write minus H dash upon H in bracket minus D upon UE dash. UE, minus and minus sign will be cancelled out, and now just see H dash upon H minus H dash upon H. It is the height of the image to the height of the object for the first lens, that is your objective. Height of the image upon height of the object, it is the definition for the magnification, linear magnification, which we have studied in the last some lecture. So linear magnification is height of the image to the height of the object, and linear magnification is also image distance upon object distance. So just see minus D upon minus UE, it is the image distance upon object distance for the eyepiece. So again it is showing magnification. So for minus H dash upon H, we can write MO. MO is the magnification produced by the objective into D upon minus UE. It denotes magnification for the objective. So we can write MO. So ME, sorry. So we can write MO multiplied by ME. Minus D upon minus UE, it is equal to ME. So we can write MO multiplied by ME. And this is the formula for the magnifying power of a compound microscope, which is true for any case. So we use this equation as a formula. So let this equation be equation number 1. Okay. Some technical problems are there. So let this be equation number 1. Now let us move ahead. We have not done yet. Again, the formula has to be driven. So let us see, formula has to be derived. So let us see what are the further steps we are going to take. Another is, now we are going to calculate the value of MO, we are going to calculate the value of ME, and then going to put these two values in the equation number 1. Let us see what we are going to have. So first of all, magnification produced by the eyepiece, we are going to write. Magnification produced by the eyepiece is given by ME is equal to minus H double dash upon minus H dash. Why both are negative? Because the image H dash is also inverted. The image H double dash is also inverted. That's why the both are written negative. It can further be written as in terms of image distance and object distance. So it is equal to minus D upon minus UE, which is further equal to D upon UE. Minus and minus sign will be cancelled out. Now we are going to write the thin lens formula, and the thin lens formula is 1 upon F is equal to 1 upon V minus 1 upon U. We are going to write this formula for the eyepiece. So for F, we can write Fe. So we are going to write 1 upon Fe is equal to, in place of image distance, since the final image is at D, so we are going to write minus D because we are moving leftward, minus 1 upon minus UE, minus for the same region. Now we are going to multiply the whole equation by D only. So we are going to have D upon Fe is equal to D upon minus D plus D upon UE. Then the next line we are going to have D upon Fe is equal to minus 1 plus D upon UE. So from here we calculate the value of D upon UE. So we are going to have D upon UE is equal to D upon Fe plus 1. D upon Fe plus 1. This is the value of D upon UE, and if you remember that D upon UE is equal to ME as written in the first equation of this page. So this is the value of ME indirectly. Let this be equation number 2. D upon UE is equal to D upon Fe plus 1. Let this be equation number 2. For objective, magnification is given by image distance upon object distance. So image distance is VO. VO is V for image distance. O is for objective. Minus U because again the object is leftward. So we should write V upon minus U. Let this be equation number 3. Now putting the values of ME and MO in equation number 1, from 1 to 3 we get capital M is equal to my VO upon minus U in bracket D upon Fe plus 1. This is the formula for the magnifying power. But we are going to take some approximations here, and these approximations are there for the second case also. So please remember the approximations here. First thing, if you remember, I have told you the object has to be kept very close to the focus of the objective. That's why the object distance for objective, which is U, can be taken approximately equal to FO. Okay. Moreover, we have defined that image formed by the objective, which is between the focus and the optical center of the eyepiece, if this image goes nearby the object, the final image gets magnified highly. So what we do, we adjust the separation between the lenses such that the image formed by the first lens, which is your objective, falls very near to the second lens. So the image formed by the objective is very close to the eyepiece, and hence image distance of the objective is approximately equal to the separation between the lenses, and which is defined by capital L. So VO can be taken as capital L. It is not there in the diagram, it is further approximation considered. So in place of VO we should write L, in place of UO we should write FO. So we are going to have capital M is equal to minus L upon FO in bracket D upon Fe plus 1. This is the final formula for the magnification, for the magnifying power of compound microscope when the final image is formed at least distance of distinct vision. Okay, let us move ahead now. The next thing is when the final image is formed at infinity. Let us see the ray diagram first of all. In the ray diagram, as you can see, now the image formed by the objective is so adjusted that it falls on the focus of the eyepiece only. And whenever anything on the focus, the image makes its image at infinity. So what we do, all the things are same, only the eyepiece is shifted towards right side so that its focus coincides with the position or the bottom of the object, so that object comes on the focus only and the final image is found at infinity. This condition is also called relaxed condition or normal adjustment. It is not there in the written form. Please listen to it very carefully. This adjustment of lens is called normal adjustment or relaxed position, relaxed condition for eye, because our eyes are relaxed when they look the things which are very farthest from it. Muscles are relaxed in condition. That's why this condition is also called relaxed condition or normal adjustment. In the board examination, this case is being asked in the name of normal adjustment only. So you have to understand it very clearly. Okay. Now we define magnifying power in this case. So in this case, magnifying power is given by magnifying power of simple microscope in this case particular is defined as the ratio of visual angle subtended by the image formed at infinity to the visual angle subtended by the object placed at the least distance of distinct vision. Means object is there only, it is there in the least distance of distinct vision, but the image is now at infinity. Okay. As you have noticed till now we have done 4 cases, so we have defined magnifying power 4 times. So you must have noticed a pattern that for magnifying power the object distance is fixed. It is always there on the least distance on the least distance of distinct vision, but the image distance changes as per the cases. In the very first case, in the simple microscope, when the image was at capital D, so we defined magnifying power to the ratio magnifying power as the visual angle of the image at D to the visual angle of the object at D. Then the image goes at infinity. Then we defined visual angle subtended by the image at infinity to the visual angle subtended by the object at D. Again the object distance is D only. Just we have defined for the compound microscope when the image was formed at capital D, that it is defined as the ratio of visual angle subtended by the image at D to the visual angle subtended by the object at D. Now visual angle subtended by the image at infinity to the visual angle subtended by the object at D. So what you have to take from here, you have to take from here that the position of the object is fixed. It is at capital D only in case of microscope, whether it is compound microscope or simple microscope. But visual angle subtended by the image changes as per the condition. Where the image is, according to that we define visual angle subtended by the image. Okay, let us define it mathematically also. So mathematically we should write m is equal to visual angle subtended by the image at infinity to the visual angle subtended by the object at capital D. So again with the same procedure we are going to go. M is equal to beta upon alpha, which is equal to tan beta upon tan alpha. I have told you the story. Beta and alpha are very small, so that beta can be replaced by tan beta and alpha can be replaced by tan alpha. Now tan beta is equal to, as you can see in the ray diagram, let me show you. Here it is b dash a dash upon eb dash. In this very triangle it is there, and tan alpha is in this triangle ba upon e dash b. E is for eyes, so e dash b. It is e dash. Here it is e dash. Okay. Now we put the values. B dash a dash is minus h dash upon eb dash. This time it is equal to focal length only. So we should write directly minus fe. In place of ab we have written h. In place of e dash b we should write minus d, because the distance is leftward from e, so we should write minus d. Now what happens? Just adjust the fraction over here, so we are going to have minus h dash upon h in bracket minus d upon fe. Minus h dash upon h is the magnification produced by the objective. So what happens? In place of minus h dash upon h, it is mo. D upon fe, minus sign cancelled out. Now in place of mo, that magnification produced by the objective, it should be written as VO upon U, image distance upon object distance. So this is the formula for magnifying power when the final image was formed at infinity. But if we take approximation, just I have told you in the previous case, so we are going to have taking approximations. Capital M is equal to L upon minus FO multiplied by D upon FE. So this is the final formula for the magnifying power of compound microscope when the final image is at infinity. I thought not to include a telescope in this, because in telescope and compound microscope they are very similar to each other, means construction wise, working wise. conceptually they are far different thing, use wise they are far different thing, but when we do derivations, when we do definitions, so they are very similar type. There is a kind of mixture there, that's why I have not included telescope here. One more thing, please correct over here in the diagram, it should be objective, it should not be eyepiece. It should be what? Objective, and it should be eyepiece. Name of the lens I have put wrong, please make it correct. It should be objective and this should be eyepiece. Okay, so now you must understand that compound microscope is going to be a very important topic. Simple microscope, compound microscope and telescope, we have to study these three topics in a very important manner, because optical instruments are always very important for your board examinations. Moreover, what happens every year, either from the compound microscope or telescope, one question is always there from these two topics. Either it is compound microscope or astronomical telescope. The astronomical telescope we are going to do in the next lecture, but this compound microscope, please do the derivation at least 3-4 times, so that you must remember the derivation is asked for various cases. As I have told you, this case is asked very frequently when the final image is formed at infinity, but it is not asked in this manner. It is asked in the name of normal adjustment or relaxed condition of eye. This is all for today. What is your home assignment for the day? Let us see. Home assignment. The very first question is, why a compound microscope has eyepiece of larger aperture? If you have listened to the whole lecture very carefully, in the very beginning I have told you why is it so. Let me give you a hint. It is related to the brightness of the image. Okay, so just try to, if you have missed that, listen to the lecture very carefully again, and in the very beginning of 5 minutes, within 5 minutes you will get your answer. Second question is, the total magnification produced by a compound microscope is 20, while that produced by the eyepiece alone is 5. It is there the magnifying power, that capital M is given 20, but the magnification produced by the eyepiece, that is a small m, is given 5. When the microscope is focused on a certain object at a distance between the objective and the eyepiece is 14 centimeter. Whenever this microscope is focused on a certain object, the distance is given, it is 14 centimeter. What you have to find out, what is the focal length of the objective and the eyepiece? You have to tell the focal length of the objective and the eyepiece. Okay, you have to apply the formula. Easy question, it is not very difficult. And the third question is, write the uses of compound microscope. It is used in biology labs, it is used in everywhere. I have told you in the beginning. Go through the lecture from the very beginning, you'll come to know. This is all for today. I hope you are doing good. I hope you are doing the assignments which I am giving at the last of my lectures. I hope you are safe. Tomorrow we are going to do astronomical telescope. An astronomical telescope is very important for the board examination. So you have to prepare these two topics very carefully. Compound microscope, today's topic, and tomorrow which we are going to study is astronomical telescope. This is all for today. Thank you.